All right, I see the timer. Hey, students. So we are back again at the video level so that you have the assistance you need to be successful with these assignments. This is the last major grade, and then I will also be doing some videos for the daily works. Now, just to remind you, these videos are not here to give you answers. They are here to help you process so that you are able to effectively show the math skills you need to get the grade you are looking for. Now, Module 4, Topic 1, Assessment. Remember, Module 4 mostly dealt with expressions. There probably were like a couple equations on here, but mostly it was expressions. We've recently just gotten into equations. So let's begin. And like I said, we're not stopping until this assignment is done. I will only help you break it down. Like I said, I'm not here to provide you answers. I am here to make sure you understand the skills needed for these types of problems. So let's begin. Question number 1. What is the value of the expression shown? So remember, you should have a piece of scratch paper with you. What are we looking for? The value of the expression. If you need to remember, what is an expression? Numbers and operations. Now, what numbers and what operations? Usually that is given to you if you need to find the value of it. Now, looking at this expression, now that we know what we're finding, what do I need to do it? Well, first I need numbers and operations. So here we have 24 minus 5 squared. So I have numbers and I have operations. Next, since it looks like I have more than one operation, what are we going to use to solve this problem? Well, when we have more than one operation, you use PEMDAS. Now, if you're wondering why I spread that out, because I'm supposed to use my pencil here, remember PEMDAS has 4 steps, and all of it needs to be done from left to right. These especially, but everything is done from left to right. Yes, these specifically, but everything is done from left to right. So you would just use PEMDAS to answer that question. Moving on. On the next slide, number 2. Directions. I highly recommend reading the directions instead of asking me what you're supposed to do on a test. I had some of y'all ask me what you're supposed to do, and when I looked at the test on your computer screen and read the direction, it clearly told you what to do. So please read the directions. Stop asking me, think I'm going to read it for you. I am not. Read the directions. It's not my test, it's yours. Drag and drop the correct answer choice to each answer blank. Use drag and drop to match the correct expressions with the statement or the correct statement with the expression. I think this is a typo on my part. It's only supposed to be one though. So obviously I can't drag and drop, so I'm just going to write the numbers. When you turn this into Schoology, you will be able to click and get a drop down of, click and drag this to where it needs to be. So that's neither here nor there. Excuse me. So what are we supposed to be doing? Let me fix my text box. Match the expression with statement. Statement in this case just means number sentence. Not number sentence, because number sentence is an expression with a sentence. So we're either going to be given the expression and have to match it with the statement, which is a sentence, or we're going to be given the statement and have to match it with the correct expression. One of the two is going to happen here. So let's look at what we got. 7 times a number, P, subtracted from 250. Well, to help you break this down, we have a number. This one says a number, but since we don't know the number, it's going to be a variable, which is P, and it actually gives us the variable. And we have a number. Here we have an operation, and here we have an operation. So when looking at the answer choices, you are looking for one where it has two numbers, one variable that's P, and two operations. Now remember how I told you when reading this what you're supposed to do with the subtracted from. So remember, subtracted from, so what is going to go first? Remember. Now, for the second one, we have 8 times P cubed. 8 times P cubed. That is how it reads. So you need to figure out which one of these works with this expression. Then we have the sum of a number, W, and 58. Well, we have a number. We have another number that we don't know, but we know the number is W. And then you should remember what sum is. Sum is an operation. Now, what operation? You need to remember, because we didn't talk about being good, understanding your vocabulary, because understanding your vocabulary will help you understand math better. So operation, we have a variable and we have a number. Now looking at your choices, decide which one goes inside of the box. Number 3 is next. So let's move on to number 3. Number 3, Mr. Gonzalez shows students part of the prime factorization of 90. One factor is missing. So we have 2 times 3 squared times blank. What number completes this prime factorization? So what are we looking for? The missing number. We're looking for the missing number. Now, how are we going to arrive or identify the missing number? What do we need to do? Well, the missing number is based on prime factorization. It's based on prime factorization. What is prime factorization? Break the number to prime factors. Okay? But then you got to know what prime factor or prime number is. Prime number, well, factor has a totally different thing. So a prime number when a factor only has two, well, not factor then, when a number has only two factors. Then you got to remember what a factor is. Factor, a number used in multiplication. Now, by the time you get to that, you should remember what multiplication is. So we are trying to find the missing number by doing prime factorization, which means we're going to be breaking a number down to prime factors. Prime number is when a number only has two factors, and a factor is when a number is used in multiplication. Now, if you're saying, hey, I still don't remember how to do this, fine, I'm going to show you how to do prime factorization, but I'm not going to use 90. I'm going to use a different number. So I'm going to use 60 to show you how to do this if you don't remember. Now, remember, there is a couple of different ways. I'm only going to show you one way. If you want a different way, I would suggest you look it up on YouTube. So we have 60. I want to find the prime factorization of 60. Well, first you have to decide, does 60 have more than 2 factors that you can use to get it? And remember, factors are multiplication numbers, what you use to multiply with. Well, I actually can use more than 2 factors. Matter of fact, there are quite a few factors I can use, but the one that comes to mind is 6 and times 10. Now, you can use 3 times 20. You can use 2 times 30. You can use 4 times 15, 5 times 12. We got 6 and 10. Like it's got a lot of different ones you can use. Feel free. Because trust me, even if you don't use 6 and 10, you're still going to get to the same prime numbers. Or prime factors in this case. So I came up with my 2 numbers. 6 times 10 gives me 60. So as long as what I have here equals the number above, we're good. Well, now let's look at 6. Can I think of 2 numbers that give me 6? Yeah, 1 times 6. But that means it only has 2 factors if I have to use 1. But I can actually get to 6 using 2 different numbers, which means it actually has a total of 4 factors. So this has to be broken down again. This can be used with 2 times 3. Now, 2 times 3 gives me 6. Remember, as long as this equals this, you're good. Well, let's look at 2. 2 times 1 gets me 2. Nothing else really gets me 2. And you're not allowed to use decimals. It has to be a whole number or an integer. It depends on if this is negative or not. So I'm done. 2 times 1 is the only thing I can use. And when you're using this tree, you're not allowed to use 1. 3, I can do 3 times 1. And that's about it. Because remember, we cannot do decimals and we cannot do fractions. It has to be 2 whole numbers that are factors. So we're done. With this side at least. Let's go over here to this side. Looking at 10, can I think of 2 numbers besides 1 and 10? Actually, yes, I can. 2 times 5 also gives me 10. So now I'm at 2 times 5. Well, we already know 2 is prime because I can only use 2 times 1 to get that. Now let's look at the 5. 5 times 1. And unless I want to use a decimal, there's nothing else I can use to get 5. Or if I want to use a fraction, which I can't use either. So here are my prime numbers, 2, 3, 2, 5. Now remember, when you're doing prime factorization, you write it from smallest number to biggest number. So we got 2 times, because all this is multiplication. You know what? I'm going to use the dot. I don't like using the X. Times 2, because I had 2 of those. Times 3, because I had 1 of those. Times 5, because I had 1 of those. Now, if anything repeats, we're going to write an exponent for it. Now, out of my 4 numbers, I do have a number that repeats itself, 2. So I'm going to combine these together. And instead of writing it twice, I'm just going to make it an exponent that lets me know I have 2 of those so that I can write a shorter number sentence. So 2 squared times 3 times 5 is the prime factorization for 60. Okay? Now, you really just have to do the same thing with 90, but you ain't you can't use 6 times 10 because 6 times 10 doesn't give you 90. Think of two numbers that can get you 90 and break it down until you get two prime numbers. If you do not know all of the prime numbers, matter of fact, I might upload that video into the daily work. Well, not daily work, major grades folder, just in case you need help with prime factorization. Because there's a very good song on YouTube that tells you the prime factors between 1 and 100. Yeah, I'll do that after I finish this video. All right, moving on. I didn't forget what number I'm on. All right, that was number 3. Let's go to number 4. Number 4, determine the value of the expression. So we have -5 times 3 plus 10 divided by 2. So what are we doing? Well, we're actually doing the same thing we had to do on number 1. The value of the expression. Remember, expressions are numbers and operations. Now, is there a limit on how many numbers and operations you can use? No. No, there's not a limit. Now, how are we going to do this? Let's see what we got. So we got 4 numbers, and I'm looking at 3 operations. So what are we going to do if we have more than one operation? If you said PEMDAS, you are good. If you couldn't think of it, I need you to study a little bit more. So remember, PEMDAS is a 4-step process. You need to do everything from left to right. So I leave that to you. If you don't know how to use PEMDAS, either look at your notes, because we did problems in class, look over your review, because we had to solve one of these. And if that's not good enough, look up a YouTube video. Number 5. Number 5 is a little bit long. All right. Serena bought 5 shirts for $6 each and spent $7 on lunch. She paid for the shirts and lunch using her debit card. The change in the balance of Serena's checking account can be represented by the expression shown. Excuse me. 5 times -6 plus -7. Which integer represents the change in the balance of Serena's checking account from these purchases? So, what are we looking for? Well, the change in the balance. Because she spent money out of her account, so the balance is going to change. We need to know the change in the balance. Now, how are we going to do this? Well, let's get a little bit more information. What is the answer going to even look like? So if I look at my answer choices, and even if you reread this question, the answer is going to look like an integer. So that means it's either going to be a positive whole number or a negative whole number. But along those lines, it's going to be a positive or negative whole number. So you don't have to worry about dealing with any kind of decimals or fractions. Also, they gave you an expression that has more than one operation. And what do we use when we have more than one operation? If you said PEMDAS, congratulations, you are starting to see the light. If you have not or did not say PEMDAS, I need you to work a little harder. All right, here we go. So break it down into 4 parts. Make sure you do everything from left to right. So this one, check everything from left to right. This one, check everything from left to right. These two you look together, check everything from left to right. So whichever one you find first, that's the first one you do from left to right. Add and subtract from left to right. So whichever one you find first on the left, and then keep going to the right until you finish it all. So that was number 5. Number 6. Regina writes the expression y plus 9 times 3/4. Which expression is equivalent to the one Regina writes? Here we go. So, what are we looking for? Equivalent expression. Now, equivalent expression means similar with same answer or value. I probably prefer the word value to answer, but they're similar with same answers and values if you solve them. If you solve them, they should wind up being roughly the same thing. Now, excuse me. Whew. Now let's see what's going on here. We have 1, 2, 3. If you count this as a fraction, if you count it as division, this is 1, 2, 3, 4. So it has 3 numbers or 2 numbers. Like I say, if you count this as the fraction as 1. But I'm looking at the answer choices, and you might want to count it as 2 because they turn the fraction bar into a division sign. So we have 1, 2, 3, 4, 3 numbers, 1 variable, and we have 1, 2, 3 operations. Now, it can't be something outlandish like subtraction when there's no subtraction. So if it would have gave us any subtraction, then you would just cancel it out. Now, there are a couple of different things that you can use to make this equivalent. Now, one of the things you could use is the commutative property. Now, remember, the commutative property means I'm going to move from one place to the next. In the case of this one, I would just move a number from being in front to in back, and from back to being in front. For example, if I had a plus, well, let me use some actual numbers so you can see what I mean. 4 plus 5 is now 5 plus 4. That's commutative property. I took one number, moved it over here, took the other number, moved it over here. They basically just switch positions. Okay, they switch spots. That's the commutative property. You're just switching spots. So you can look for one where those two just switch spots. Now, the only thing about this is, notice how the commutative property doesn't have anything attached. Only these two numbers can switch spots. But I will let you know, if one of these numbers needed to be used in a multiplication problem, remember, multiplication comes before addition. So I wouldn't be able to use commutative property if one of these numbers needed to be multiplied with. So let's look at another one. You have the associative property. Associative is exactly what it sounds like. You associate. So this is what I told my after school tutorial group for STAR. It's like hanging out with a friend one day and then you hang out with your other friend on the next day or later that day. You hung out with your friends interchangeably throughout the day. So let's say you and buddy number 1 spent the morning together, but you didn't talk to buddy number 2. Well, later in the evening, you talk to buddy number 2, and buddy number 3 is by themselves in the evening. But you have effectively talked to both buddies. Okay? You have effectively talked to both buddies. So I associate it with this number first, and then I switched associations later. Now, realize because all of this is addition, it does slightly have a commutative property to it. That's why I'm able to switch it out to associate with a third number if necessary. Now, this property really isn't going to help you with this here unless you figure out what's going on between here and here, because there's no parentheses here. So you're most likely not dealing with a situation like this. Oh, also, commutative property also works with multiplication. So remember that, which is the same here. So both of those work with multiplication and addition. They don't work with the other two for obvious reasons. So if none of that helps you solve this one, there is a couple of other properties you could look at, although they don't apply to this situation. So I will just name them, but I won't type them up. One is the identity property. Identity means nothing changes. So you are literally either adding with 0, because anything added to 0 stays the same, or you're multiplying it by 1, and because anything times 1 stays the same. Those are the identity properties. This is not that. The other one you have is the inverse property. Well, additive inverse property. It has a specific operation it goes with. Additive inverse property says I'm going to add and take away the same amount to get a 0. So the goal of that one is to get 0. The only problem with this, we don't know what this equals to, so we know it's not additive inverse. And then you got the inverse property for multiplication, which means you have to do the reciprocal of what you have. And yeah, we're not doing that one either. The last but not least is distributor property. Now this one says, if I have a number, usually you're not going to see that multiplication sign. I put it there for a reason. If I have a number touching a parentheses, and I have some numbers in a parentheses, I am allowed to multiply everything inside the parentheses without having to solve it first. Now, this was created because variables were introduced to math, and you still needed to have a way to simplify a problem when you didn't know all the numbers. So that allowed us to effectively skip over parentheses if and only if there was a number outside the parentheses that you could multiply with. Now, this does not include in middle school, because it may change in high school. Don't hold me to it. This does not include exponents. Exponents, you need to solve everything or try to solve everything inside. And if you can't do it, leave it alone, because you ain't learned how to get rid of an exponent yet. You learned that in 8th grade. All right. So if you have a number touching a parentheses, which means those two things need to be multiplied together, you can simply multiply everything inside the parentheses by that number. And you would still get the same answer. Now, if you're like, no, you won't, well, let's try and see. So here we have 4 times the quantity of 3 plus 4. So 3 plus 4 gives me 7 times 4 gives me 28. Okay, it equals 28. Now, let's see if that's the same thing over here. 4 times 3 is 12. And then 4 times 4 is 16. And I'm going to add 12 and 16 together. That gives me 28. So this proves this method does work. If you have a number touching a parentheses, you are allowed to multiply it with everything inside of the parentheses. But that's only if it's multiplication. If you see any kind of operation here, because sometimes they'll trick y'all and put a plus. If it's a plus, you can't do it. If it's a minus, you can't do it. If it's division, you can't do it. It only works if it's multiplication. And most of the time, you will not see the sign. It will just look like this. Okay? So, have an understanding of these properties, but in all honesty, you might just have to try your best with this one. But I would say, if you don't want to take that chance of getting this one wrong, what you can do, there is another option if you don't understand any of these properties I just sat here for the last 4 minutes and talked about. You can use what I told y'all before is called substitution. Substitution is when you replace a number, when you replace a variable with a number. You replace a variable with a number. Now, the only suggestion, the only thing I'm asking you not to do, don't use the number 1. Okay? That's all I'm asking. Don't use 1. Use something greater than 1. That's all I ask. Use something greater than 1. Put it in for the y. Solve this. See what you get, and then put it in for these y's. Solve and see if you get the same thing. Because if it is equivalent, it should be similar. So all of these look pretty much similar because all of them have addition, division. It has the multiplication here. This one has addition, multiplication, division. Multiplication, division, addition. It all has the operation. It has all 4 parts. So they are similar, but which one will also give you the same answer or value? So that means using substitution, put in a number for y and see if you get the same answer. And if you do, that is equivalent. All right, moving on to number 7. I hope this is not an hour-long video, but we'll see. Which of the following expressions represents the area of the figure below? And then we have this. Okay, so what are we looking for? Expression that represents area. So an expression that represents area. Well, you got to understand area first off. So looking at here, we have a 12, we have 2x, and somewhere along the lines, we used one of these to get both of these. Okay. I don't know how to explain this one any further than that. We used one of these to get both of these. So I would just say test it out. Now, there is one answer choice I am going to cancel for you because you shouldn't choose this at all. Matter of fact, I need to check really who chose this one because we need to have a talk because I never showed you anything like this in class. That is an algebra type answer. And that is B. You should not have chosen B at all. And I'm going to show you why. This is not what we do in middle school. This is algebra. So what happens is, you remember how I told you if a number is touching a parentheses, you are allowed to multiply with everything inside that parentheses? Well, that also works for whole expressions. So this is what we're actually trying to get you to understand for later on when you get to algebra, because you're going to be doing quite a bit of these. So you are allowed, if 2 parentheses are touching, to multiply what's inside both of them with both of them. So that means I can use the x with the x and the x with the 6. I can also use the 6 with the x and the 6 with the 6. So this means I'm doing x times x, which is going to get me 2x. Then x times 6, which is going to give me plus 6x. Then I do 6 times x, which is another 6x, plus 6 times 6, which gives me 36. So I have x squared plus 6x plus 6x plus 36. Then, of course, I am required to combine like terms. Well, this one has an exponent, these don't. This one doesn't have a variable, but these do. The only one that is similar is these, and both of them have a number and a variable only with no exponent. So that would give me x squared plus 12x plus 36, which would be the final expression. Does this look familiar to you? Unless you have an older sibling that has been teaching you algebra, you've never seen anything like this in my classroom, because this is algebra and you're taking pre-algebra, two totally different things. So I will tell you, I should not see you choosing B, because B is algebra and we don't do that here. Well, we do if you get in if you're in advanced classes, then you might be going to algebra in the 8th grade, because we do have algebra here in 8th grade. But that means this one, or this one is one of your answer choices. And this is also related to the properties I talked about in the previous question. So did they use the commutative property, associative property, distributive property, things of that nature. All right, on to number 8. So it says select the best answer choice to describe the property and the simplified part of the expression. Now notice it has 2 parts. Number 1, which is this box, you're going to be doing the property. In this box number 2, you need to figure out what is missing. So it's 5x, 8x, or 6x. One of them goes in that box. Excuse me. Try not to yawn. All right. In the third box, we have more properties, which is the same properties we had in number 1. And then for number 4, we have these answer choices that can go into number 4. So we have 4 of these when we had 3 of these for number 2. Now, what are we supposed to be doing? Well, we have to find not find. You don't have to find the property. You just got to identify it. So they say describe. You just got to identify the property. Identify the property and simplify the expression. Well, we already talked about what an expression is. What is simplify? Simplify is to shorten or make smaller. And when I say make smaller, I mean in value. Usually simplify, you'll see it with fractions, and you're making the numbers smaller. So you're just making it, you're making not the value smaller. The value is the same. You're making the numbers smaller. But if you don't know all the numbers, then all you can do is shorten it to very simple terms, but you can't solve it. And in the case of this one, since we do have a variable, we're not going to be able to solve anything, but we can make this shorter than what it is. Now, for the first one, if you look at what changed and what stayed the same, I've already talked about these 3 properties in a previous question. The only one here that I'm going to talk about that's new is combining like terms. Although I did mention combining like terms, but let's break down what that actually means. So combining like terms. Combining like terms is your new adding and subtracting. So when you are adding or subtracting, you are now combining like terms. So combining like terms, adding and subtracting. So if you see this combination of words, that means you're adding and or because you could just be doing one or the other, or you could be doing both. Adding and or subtracting. Honestly, I'll leave it from there. If you need more details, just let me know. Number 9. Number 9, which expression is equivalent to 3 times the quantity of x plus 6? So, what are we trying to find? Equivalent expression. Equivalent. Similar. With same value. So it should have a similar combination of things, but it's not going to look exactly the same. But when solved, it should give you the same value. Now, this is a property type question, so you are going to need one of the properties. I'm not going to tell you which one, because I need you to figure it out for yourself so you're able to identify it later. So you do need one of the properties. Now, if you don't want to use one of the properties, that's fine. The other thing you can do is substitution. Now, for the ones that didn't understand me when I said substitution earlier on, substitution is basically when you place a number inside to see if it gives you the same thing. Now, I'm going to show how substitution works, but I'm not going to use the same problem. So let's say I have y plus 28. Okay. Where y is equal to 5. Now, I literally told myself y equals 5. I'm just choosing y equals 5. There are problem types that you will see like this where it will give you an expression and it will tell you what the variable equals, and you have to use what they tell you to use. But in this case, I'm just making this up. So my number is going to be 5. So substitution works this way. I am saying that y equals 5. So that means I no longer have to write this y here. I can substitute the 5 in its place and then proceed to solve and see what I get. In the case of this one, it's going to give me 33. But if I had a different number, it would have gave me a different answer. So it just depends on what number you're putting in and what you have to do to it. In this case, all I had to do was add with it, and then I was done. Sometimes you may need to multiply. Sometimes you may need to divide. Sometimes you may need to subtract. You just do what the problem is telling you to do. Number 10, which is the last question for this test. Directions. Choose the correct answer for each row. So if you don't know what row means, row is from left to right. Okay. So you need to choose one answer choice from left to right. So row, left to right. So one per row. Use the match table grid to identify if the expressions represent or does not represent the model shown below. And then we have represents and does not represent. All right. What are we supposed to be doing? It needs to represent or does not represent, because they actually have both options here. So it either represents or it doesn't represent the expression in model. Now this may seem like a not. Represent means yes, the expression matches the model. Does not represent means it don't match. So basically, to me, this is nothing but a match table grid. They kind of gave you a hint here. You're just matching this up. Now, since you have to choose one, let's go back to the directions. Choose the correct answer for each row. Since you have to choose one for each row, that means It either represents or does not represent. It cannot be both. It cannot be both. So it's either this one or this one, but that means you need to choose one per row. So by the end, you should have 3 answers, each one in a different row. Now, this is one of those ones we did talk about in the review. So I would suggest you go look over your review or watch the review video if you need further help to answer this one. But that is the last question for this Module 4, Topic 3. I would suggest if you need help with any of these questions, if they weren't answered in this video, then go watch the Module 4, the review of Module 4, Topic 1, so that you could get a little bit more in-depth, because in that one, I do explain a little bit more than I do in this one. For the simple fact, that was a review and we did it in class, so I don't mind going a little bit more in-depth. This is a more of an independent assignment to see what you know, which is why I didn't go that in depth. I just kind of gave you a little bit of guidance to help you along. But if you need further guidance in this, then let me know and I will see what I can do. To that end, I got more videos to do, so this one is at the end, so bye.